global refrigeration market is expected to record a value of $19.57 billion in 2024, and the global natural refrigeration market size will reach $30-70 million in 2025. The market is dominated by fluorocarbon refrigerants due to their increased demand for production of ACs and refrigeration units because of their advantages of stability, non-flammability, and low toxicity. Natural refrigerations have GWP values as low as 10 and are cheaper than synthetic alternatives. A few notable trends may include the increasing use of dehumidifiers, accelerating the R&D spending for energy efficiencies, rising demand for natural refrigerants, and use of IoT-enabled refrigeration solutions for equipment monitoring. Today, on this note, you're going to be a part of a live interactive session on a shift towards natural refrigeration technologies. Our today's experts panelists from refrigeration industry will discuss the advantages of natural refrigeration, natural refrigerants, their cost-saving capacities towards energy efficiency and maintenance. Also, we will discuss the challenges and IoT-enabled solutions for shifting towards the natural refrigeration. Ladies and gentlemen, it's an honor and privilege for me to introduce you to our today's distinguished speakers, Mr. Nagahari Krishna L., Director, Industry Affairs and Regional Hotspots at Danfoss, India, Mr. Wilson Lawrence, Vice President and General Manager for India Engineering Technology Center at Train Technologies, Mr. Nitesh Dua, is the design engineer at Bombay Ammonia Refrigeration Company. So delegates, get ready for an interactive session on a shift towards natural refrigeration technologies. Our first submission for today's session will be presented by Mr. Nagahari Krishna. He is presently the Director for Industry Affairs and Key Hotspots at Danfoss, India. He is one of the key leaders with Danfoss, India to support the company's continued growth in the country. He is a mechanical engineer with marine and control specialization and holds an expertise in achieving sustainable development goals through energy efficiency. Today, Mr. Nagahari will talk about towards a climate-friendly refrigeration industry. So delegates, let's welcome Mr. Nagahari Krishna.
So to start with this conversation, I welcome everyone to this panel discussion. What are the criteria to choose, an refrigerant for application?
There are a couple of criteria when it comes to natural refrigeration, natural refrigerant. Obviously, GWP, ODP is going to be a very obvious criteria there. The important point which we have been hovering around when it comes to selection is obviously the safety measures as compared to the standard guidelines what we have, right, when it comes to natural refrigerant per se. We will have very strong KPIs in place in making sure that whether we could be able to meet the safety standards, what we follow as per our AHRI standards there. That's going to be one of the key criteria. And next come the efficiency of it, right? Obviously, from a cost side, there is no question around it. We have quite a few challenges when it comes to efficiency, right? So there are various ways we are trying to address the efficiency element. For example, can we go and adjust something towards the thermodynamic cycle of the system so that we don't compromise too much in energy efficiency side of it. So that's going to be one of the key there. Obviously, the amount of charge that is also being seen as a larger constraint when it comes to hydrocarbons and CO2 there. Especially, as you know, in train technologies, we are largely into transport side of the businesses. I mean, truck refrigeration, trailer refrigeration, bus air conditioning out there. Of late, we have been seeing CO2 is being coming as a quite a good option there. The obvious reason is we have some challenges in terms of handling, in the larger volumes out there. So that's going to be one of the important criteria. To summarize, obviously, efficiency, safety standards, and how do we manage those volume of charges So these are some of the key KPIs we typically consider when it comes to qualifying the natural refrigerant process.
How do you see with the present price volatility of prices of natural gases? What can be the challenges and risks that can impact the refrigeration industry?
Yeah, like I mentioned, when we look at the affordability piece, while price is an important parameter that comes into play, the affordability does not rest just with price. While it is an important factor that comes into play. And natural refrigerants, if we are looking at natural refrigerants to move with, uh, the price in itself should not be that big a constraint. But if you look at some of the other low GWP options that are coming in, which are HFOs and other options that are there, their price does become a factor because it depends on the demand in a particular region. Where is it being produced? Are you importing it? The fluctuation of the forex and all of that come into play. But from a natural refrigerant, if you are looking at an ammonia or a CO2, generally that's not that big a challenge. But from an affordability angle, it is not just the price that comes into play, because when you are using natural refrigerants and you are trying to move from a particular refrigerant, let's say you are using ammonia, you want to move towards a cascade system or a transcritical system, the efficiency also comes into play there, where the efficiency may fall down as against the existing efficiency that is there that you are already used to. So that's a factor that where your design engineers come into play, where people like Nitish Dua are going to play a very important role, and we will probably need more and more Nitish Duas in India if we have to take this natural refrigerant road forward.
So, looking at it, when you propose ammonia as a natural refrigerant to the industry, usually what kind of hurdles you meet with?
For smaller applications, usually like a lot of compressors are not there. So it becomes expensive. If I import something from outside, then it becomes expensive. Okay, we have tried smaller systems also with DX systems, and they work very well. But somehow, for smaller systems, people would go for HFCs. The reason being that ammonia would be costly as a refrigerant over there. The system would be costly. The initial cost would be more. Other than that, if it is a residential place, then people would say, "Yaar, leak ho gaya to." Then what? If there is a leak, then what? And so people have put ammonia systems in residential places uh, with very safe, practices. But somehow there is this mindset that if it is a residential place, let's not put ammonia. And now government guidelines have also come in some states. So because we don't have proper standards, and everyone would not build such a system that it is safe, because we are not having regulatory authorities to actually monitor what is being built. So we are facing this problem that we are not able to promote it in residential places. Thirdly, sometimes people say that there could be a leakage and there could be contamination. If I mean, if the welding and all is well, if all the standards are followed, it is very rare that it leaks. In the machine room, probably yes, during maintenance, but inside, if all the international standards for welding and inspection are followed, there is a very less possibility of a leak. But still, as sir talked about, people are saying we would like to go for CO2 with ammonia as cascade system. Obviously, because CO2 cannot be used directly, because the critical pressure is, near at 32 degrees or so. So on the condensing side, it would not be feasible. Pressures would be very high. So as a cascade, they would be using it. So that on the low side, they could get a CO2 system, and on the high side, they could take advantage of ammonia's efficiency and get a better system. Other than that, for bigger plants, whenever we go, so for food processing or for bigger cold storages, ammonia is usually preferred. because of its efficiency, and because the cost is also mostly lower than HFC installations.
Yeah. So see, Nitish highlighted a very important aspect on safety and the relevance of safety standards in India. And that's something that is very important when we look at the roadmap for natural refrigerants in India. When you look at it from a standards viewpoint or a regulatory and policy viewpoint, the good part is the BIS, the Bureau of Indian Standards, has done commendable work in this space. Today, you have adopted a lot of global standards on safety for India, and they're available for the Indian stakeholders. Specifically on ammonia, BIS has now drafted a safety standard for all ammonia-based applications. And as I last heard, I think it has already gone out for printing and it should be available. The important piece now comes in is because standards are voluntary in nature. How do you cascade this, that a standard is available to stakeholders? Because people in the plant room should know that this is a safety standard that is available, and I need to follow these standards and protocols that have been given to me for me to be safe. It's the important part here is that it is him that has to be safe. If he is safe, the plant is safe and everybody is safe. And a lot of challenge for people when they look at natural refrigerants is it's not the cost or the other parameters that come into play. The safety comes into play for them. And if you have the right skill sets in place and the skilled people there to take care of the safety aspect, automatically the natural refrigerants offtake will improve. So one thought process that is there is, like you have a driving license if you have to use a motorcycle or a car, you need to look at having a driving license for people who are in these plant rooms. And that will kind of enable the industry to move forward.
What are the challenges in creating such standards for the industry for natural refrigerants?
So obviously, when we try to bring standards, certainly it will bring confidence for all of us in terms of making sure that our equipments are safe. People who are going to use these equipments are safe there. The other side is it obviously bring a little bit of cost additions there, especially in markets like India where things are very sensitive towards the cost. Not to a larger extent, by the way. To some extent, especially in the residential market, split ACs, I guess many of us know that it is an extremely cost-sensitive market, right? So obviously, anything towards the safety is going to bring some addition to the cost. So how the people mindset is going to get shift in that space in making sure that, well, this is, I mean, I'm ready to pay anything extra just because of my safety, right? I mean, which Krishna just highlighted out. That is one of the little bit of challenges what we see in our region. That's what I'm hearing from the businesses. But globally, from a standard perspective, we have been following almost all the standards, and our Indian business team is also is been very encouraged to follow some of the safety standards which we've been following in the global markets. To a larger extent, in developed nations, we are not seeing any much of challenges out there.
So I would like to add this, that based on my experience in the US, so what they do is they have certain set of procedures. They call it PSM, Process Safety Management, and they have licenses for operators. So if you follow the PSM, and every company has to give a file which states what are the procedures for their plant, and if the operators are trained, so I have a operator 1 license in the US, which means that I know all the safeties of the system. So there are different levels of operation, and all those levels, operator 1, operator 2, expert operator, and further on, they have different levels of licenses, as Sir talked about. So when we bring such things into the system where we have process safety management and we have licensed people who are first told about the security of the safety of the system, and then they are allowed to operate the system. If we bring certain things into these things into the system with reinforcement from the government side, then I'm sure we can easily pull off the natural refrigerant thing.
How do you assess the efficiency among natural refrigerants as well as other alternatives?
Till now, how much I have done, see, COP is one part of the system. We can calculate the COP of the system. But other than that, uh, I have seen many cold storages. So, say it is a 5,000 metric ton cold storage. This is a very standard cold storage in India. So, one of the companies, they installed a HFC based solution, and we installed a ammonia based system. So, the electricity bill was quite different. So, electricity bill in itself tells you what is the efficiency of the system. And operation in both the stores is door openings and all, they are almost same because it will load in the beginning, it will stay for a long time, and then it will open. Similarly for controlled atmosphere cold storages where similar thing happens. So in that case, the electricity bills will tell you what is the difference. Other than that, if you want, you can do a COP analysis that will give you much more idea.
Probably I'll pick up in a little larger perspective, more from a thermodynamic standpoint. When you take ammonia as an example, that all the speakers said ammonia is pretty efficient when it comes to HFCs. Right? But the point here is, in some of our investigation, what we have done in ammonia, it certainly forces us into the low efficiency technologies that will hurt the efficiency or the efficiency advantage, what you're taking advantage of, right? For example, I mean, I was indicating the beginning there, copper tubing is being quite popular in our industry just because of the heat transfer efficiency, what it brings in, right? So obviously, especially in the evaporator side of the segment, we cannot take advantages out of it just because we lose efficiency. And on the condenser side of the approach, the temperature is very, very poor when it comes to, I'm referring more towards air cooled or water cooled chillers there. So in these situations, to go back to your question, how do we assess those efficiency here is, to a larger extent, we are trying to pick up some alternate materials which could be able to overcome the efficiency loss, what we're seeing there, right? Plus, there are a lot of investigation is getting into the component levels, whether it could be compressor side of the efficiency, etc. There, expansion wall, TXP valves. There are quite a lot of efforts is going on to compensate, the efficiency which we are losing out of this, so that we could able to compensate, right? So that's the way we are making an adjustment in making sure that the efficiency has been taken care to a larger extent when we go into the natural refrigerant.
Until the products used, the components used are also of the right efficiency. Like if you don't have a properly automated system in ammonia, then ammonia power can also be more than the HFC based thing. For talking about copper and stainless steel, as I have designed both HFC systems and ammonia based systems, the copper efficiency is high, but heat transfer efficiency of ammonia is high. So a ammonia based evaporator and a freon maybe based evaporator, they have approximately the same size. So pressure drop in both the systems is approximately same on the evaporator side. Some cases it can be low also, depends on the circuiting. But because heat transfer efficiency of ammonia is higher, even copper being more conductive and other things, the size of the coil comes same. Only maybe 5% difference is there in the coil size.
Again, what kind of facilities we have to assess the quality of refrigerants available for the industry?
So, see, when it comes to natural refrigerants, one important parameter that what we have seen is that increasingly you are seeing within end users a lot of devices and solutions that are coming into play, which can help you in ensuring that you do not have too much of a loss of refrigerant that happens in the system. There are systems like air purgers and IoT enabled devices and valves and controls that are available, which help you in reducing the overall loss of refrigerant that happens. And if you can reduce that, there are two benefits that come in. One, you don't lose too much on efficiency there, because you continue to maintain a particular pressure in the system. And second, which is a direct benefit that comes in, is you need not keep charging the system with a lot more refrigerant, because you are ensuring that the refrigerant doesn't leak out. So these are things that are, these kind of solutions are increasingly available today. It's a question of looking at the total cost of ownership for clients. So be it Train or any other company that is there, are increasingly innovating on products and bringing those solutions into the market. But the challenge always for a lot of these innovations that come into the market is for the clients to look at the total cost of ownership rather than the upfront investment that they look at. And that's a continuous challenge that is there with every manufacturer that is there. But we need to continuously engage with clients to help them understand that.
How do you see India becoming Atmanirbhar in availability of natural refrigerants?
See, as regards the refrigerant manufacturing, at least to my knowledge, I think we do have the capability to do it. It's a question of the demand coming into place that is there, be it whichever refrigerant we speak about. I think we have a lot of manufacturers who are already producing those kind of refrigerants in India. Once the demand builds up, you will, because it's not that big a challenge according to me. Maybe my fellow panelists can throw better light on it, but to me, that's not such a big challenge.
I feel the ammonia quality in India is not that good. It is basically because ammonia comes recycled from ammonia plants and is not produced in the lab like any other refrigerant. That is why the cost of ammonia is also less probably. So I will share an experience which will help you understand how this quality affects efficiency and even creates many more problems. So we did a very small system, a direct expansion ammonia system, and everything is well, everything is done very well. We put the ammonia in and the motor is gone. And we are like, what just happened? And we come to know the percentage of water in that ammonia was very high. Now, because it was a semi-hermetic, like a sealed compressor, so motor was inside the compressor. Now the quality of ammonia was not up to the mark. And what happened is that the motor was gone and the compressor had to be repaired. So quality of ammonia, only I think there are few sources where you get the right ammonia. And that also you have to tell them, I want the right quality, then only they will give you the right ammonia quality. So yes, as sir said, that as the demand grows, the right, the right manufacturers for the refrigerant would definitely come.
Similarly, Prasad, on the quality, since we're talking about the quality of the refrigerant, well, I can share some insights on hydrocarbons, like the way Nitish just talked about on the ammonia side. This is again, we observed in one of our tests. As you know, hydrocarbons like isobutane, propane, we simply can't use it like the way we buy the fuel there. Right? There are too much of variations. We have been seeing variations in terms of contaminations. There are, as we all of us know, there are quite a few sulfur components exist in hydrocarbons. And you know that how much sulfur is reactive to materials like copper we use in our HVAC systems, right? So So we have to be extremely cautious when it comes to hydrocarbons on the quality side. But I can suggest some of the standards published, like AHRA 700. That's one of the best standard which our teams has come across, which nicely list out what are all the specifications from a quality standpoint has to be followed. So if you could able to be very watchful in making sure those specs has been taken care, then I don't think so we have much of challenge when it comes to quality side from the refrigerant standpoint.
What are the major requirements for effective maintenance practice in natural refrigeration?
We observe quite a lot of debris when it comes to natural refrigerant, whether it is ammonia or the hydrocarbons there. And these debris, as you know, this could completely twist over. If you simply take the TXVs there, right? So we have some very, very small orifices there. Any debris which could cause diverse efforts to some of the components like TXVs and compressors. So we have to be extremely cautious when it comes to making sure we are using right refrigerants and the maintenance has been taken care as appropriate. Right? So this is my quick response when it comes to maintenance side of it. And obviously from a pressure standpoint, as you know, some of the natural refrigerants operates on a slightly higher pressure. So making sure the safety guidelines has been taken care, and also a periodic maintenance, which will definitely help. A little bit of insight from a technology standpoint. This is not very specific to natural refrigeration. I'm talking in general there. Eventually that can be applied. I don't find any reason not to apply for this. We are getting into more on analytic space in terms of collecting all the sensory information which is coming out of the system, whether it is a suction pressure, viscous pressure, all the critical parameters. We have been very closely watching these data which is coming out of a system, making sure that these parameters are well under control. And these data has been shared with appropriate time to those people who are managing systems. In a way, we are handling it. So that's where we are taking a shift by data-driven approach in making sure the maintenance or the safety has been taken care. And I don't see any reason we can definitely employ those technologies into natural refrigeration side as we move on.
What will drive the demand for natural refrigerants in India?
There are applications that we can look at natural refrigerants in the near mid-term to long-term kind of a range, both in the commercial refrigeration space. In the industrial refrigeration space, if you look at India as a country, a large part of it, thankfully, is already on ammonia based. I mean, most of the large cold storages are ammonia based already. So the challenge that what I foresee is a lot of these plants which are using ammonia today, if you look at, let's say you look at a dairy plant today, and if you look at the Nandini dairy in Bangalore, for example, the dairy circle, used to be on the outskirts of Bangalore when I was a student. But today, there is a sprawling city 30 kilometers around the dairy plant. So these kind of instances are happening across the country where urbanization is kind of ensuring that the cities move out of what they were initially intended to. So there could be a tendency to move away from ammonia because it is toxic in nature. But that moving away from ammonia should not happen in a manner where you move towards a refrigerant which is high on GWP, because ODP is definitely not going to be there because that's not permitted by the regulations. So how do you ensure that these changes happen in a way which is sustainable? And that's where the research that I spoke about on using CO2 as a refrigerant for India, the cascade systems or low charge ammonia systems come into play, because then safety is taken care of. And in these plants, you can continue to use natural refrigerants and ensure that the demand continues to be there. While there is newer applications that we are looking at on the commercial refrigeration space, which will further drive up the demand. For Danfoss, energy efficiency and sustainability is the only way we believe business is to be done. So there are multiple products that we are consistently innovating and bringing them into the market. So even in the natural refrigerant space, just before COVID hit us in 2020, we launched about 6 products for the this specific industry, that is the industrial refrigeration industry, which includes a heat exchanger, an air purger system to ensure what I was speaking earlier of retaining the right quantity of refrigerant in the system, some controls. So aspects like that we have launched. The other aspect that we consistently and continuously do is innovate on the existing products to ensure that the efficiency levels are continuously improved, because you can't look at a efficient product which was 2 years earlier to be at the same levels. So even a product which was invented 85 years ago by Danfoss, the thermostatic expansion valve on which Danfoss as a company was built, is in its 6th generation today, which means that it has gone through 6 cycles, and that's the kind of innovation that we look at.
As you talked about, that we are measuring the key parameters like suction pressure, discharge pressure, and other compressor parameters, which is predicting the maintenance of the equipment. Other than that, it also gives us an opportunity to make the systems more efficient, like balancing the compressor discharge pressure to the lowest energy point, or maybe having the right amount of compressors running. So all this, it comes with all these monitoring which sir is talking about. So as a company, what we have been striving for is to make better systems every time. And I feel that in India, because like as you said, that the cost is a very important point. So because of the cost, most of the people, they will let go of the safety, and heavier equipment design is not taken into consideration in many ammonia plants. So we strive that uh, till where possible, we take all these things into consideration and make efficient systems with the right controls, so that the real efficiency which ammonia can offer is offered to the customer. Otherwise, if you don't put those equipments, if you don't put the safeties and the automation within the system, then the efficiency which ammonia has to offer, it does not come.
Great.
This is what we are lacking in. Uh, like standards are also there, like the welding standards, the inspection standards, the safety standards, which are companies following from very long time, but those are also not followed because of no government regulations. So we try that to the best of our extent, we follow all those standards and build systems which are long lasting and efficient.
We've been hearing a lot about blockchain as a technology per se, and we all know that that particular technology has been getting used in larger fintech industries, especially managing ledgers. We are exploring to see whether any opportunities to leverage those technologies in terms of tracking the refrigerant, whether it could be hydrocarbons or HFCs, to make sure that, first of all, to make sure where exactly the leak is happening before it gets into the factory, all the way up through the entire life cycle of the refrigerant, right? The place from the manufacturer to the place where the service technicians is reclaiming it or getting away with it. So that we could be able to bring people accountable in making sure that in the entire life cycle of the chain, what's really happening there. That is one of the space where we are very much in. And obviously on the analytics space, more into predictive analytics, making sure to have, we have quite a significant amount of data from our own systems there. And so we are currently putting a lot of efforts in how to churn the data, in making sure we could able to bring value proposition to our customers. Eventually, our system should be more efficient. So in the space of data analytics, blockchain, is being our key focus in our industries. All the panelists were, brought some really good, valuable experiences, be it from Krishna or Nitesh. I think I really enjoyed your perspectives, especially some of the goals what Danfoss has been put in place, which has been so amazing, Krishna, to see companies like Danfoss is taking a strong footstep into that. Nitesh, all that what you've shared is ground reality. I could able to go back to my 20 years of that experience. That's where we really learn a lot, right? So people like you know the ground reality of those things. And thank you very much, Megha and Prasad. You could able to bring all of us together and share some of our insights to the entire breadth of the refrigerant, right? From people like Nitesh, from a company like Danfoss who manufacture refrigerant, and people like us, who uses the refrigerant. So I think the way you picked up all the panel members to bring it more interactive, we really enjoy. I personally really enjoyed the session. Thank you very much once again.
We hope you enjoyed this session thoroughly. Before wrapping up today's session, we would like to thank our distinguished panelists for today, Mr. Nagahari Krishna L, Mr. Wilson Lawrence, and Mr. Nitesh Dora. I would also like to thank our editor, Mr. Prasad Nayak, for taking this initiative. Thanks to our delegates, our viewers, and our panelists. With this, we would like to announce the closing of our today's session. I request you to stay tuned with us for more such sessions. Until then, thank you and goodbye.
Thank you very much.